All right. So more antennas and feed lines. Feed lines and connectors. Let's see, feed lines are used to connect your radio to your antenna. The types of feed line include coax cable, ladder line, twin lead, open wire feed line, and I'm sure there's more, but I don't remember all of them right now. Coaxial cable is the most common type because it's easy to use, and it says no special tools are required, but most people like to use the crimp style. Now, there are connectors that don't require crimping, and all they require is a couple of wrenches to put them together, but they're also expensive. They're compression type. So you put them all together, and then you put the cap on the back, and then as you twist it, it compresses grommets inside that hold everything together. They're reusable, but they're an initial investment that are kind of expensive. So I think you remember a price off the top of your head for PL259 compression type? It's like $12, $13. They're up there a bit. But most people use the crimp type, which is what I've resisted crimps and wanted to use all solder on, but it's hard to get the amateur cables that will resist the heat when you try to solder everything. So I decided to go ahead and convert over to the crimp. So now I have a crimper with the different jaws for the different size of crimps that you have to make, but you still have to solder the pin in place. So you don't get away from soldering altogether. But there's no real special tools required. When they say special tools required, they're talking about the hard lines. Those have more different tools. Yeah. Okay, so here's a few different types of feed lines. The one you see there that the guy's got his thumb on, or finger, whatever, that is the hard line. That one there does require more advanced special tools to be able to do that. This is a regular twin lead. Well, I don't know, this might be window line, but this is what your window line typically looks like. Fortunately for me, the window line that I bought from DX Engineering has wider areas of dielectric, because that's where you have to make that cut for the little capacitance gap. But this is what you're going to see most of the time. This is your coaxial connector. You've got a shield on the outside. I'm sorry, you've got a jacket on the outside. You've got a metallic shield, and copper is better, as with most things with electronics. So you've got the copper shield, you've got a dielectric, and then you've got your copper center conductor. A lot of the times, the center conductor, if it's solid, is going to be aluminum in the middle, and then it's copper coated on the outside. There's a reason for that. Cheaper, lighter, and skin effect. Your signal doesn't typically travel in the middle of in the core of the conductor. It travels along the skin on the outside. This insulator right here, the dielectric, that's the thing that changes your, you've got we already said copper is 0.95%, right? That's your velocity constant. But this dielectric on the outside, or the insulator on the outside of your speaker wire, is what changes the speed the signal travels through it. But there's a few of them. This is called ladder line. Now, a lot of time, and I did this, and DX Engineering should be ashamed of themselves because they did it too. I called this ladder line. DX Engineering calls it ladder line, but that's window line. I was corrected by an old school ham. No, that's not a ladder line. That's a window line. And that is a ladder line. It literally looks like a ladder, because you have two conductors that are separated by spacers to maintain a common space. And for the guys that are really into experimenting and playing around and trying to see how low they can get their ratios and stuff, this is kind of thing that they will do, because those are the distance between them will determine the impedance. And so I've heard 600 ohms. I've heard other things. And so I don't know what the common distance is or what the common impedance is. But and that, yeah, well, that's what I mean. You got, yeah. So anyway, so feed lines and connectors, the important parameter of a feed line is a characteristic impedance. And I did some research one time. I don't remember if it's on here or not, but I did do some research one time about what determines the impedance. Okay, I mean, it's something that you can't really measure with any of the tools that we normally have. So what exactly determines it? So amateur radio coax is typically 50 ohms. Your TV twin lead, which is the twin lead with that's like 3/8 inch wide, I think, or something like that, or 1/2 inch wide, is typically 75 ohms. And then that window line that I use to make my antenna is 450 ohms, and the ladder line, 600 ohms. So all different types of impedances, and that's one of your most important factors of your feed line. Is the characteristic impedance, Z sub O, that's probably 0, is the impedance of an infinite length of transmission line. Coaxial cable for amateur radio is typically 50 ohms. Impedance is the opposition, we've already discussed this part, the opposition to AC current flow measured in ohms. And everybody remembers the formulas there, right? A transmission line terminated in its characteristic impedance appears as that impedance at the source. So if you've got a 50 ohm impedance feed line and you terminate it with something other than 50 ohms, it's not going to be 50 ohms at the input to the feed line either, because what you've got on the other end. Feed line impedance should match the transmitter output and the antenna input for maximum signal transfer. I can't see what that says. That's probably a result of me using PDFs rather than Bob's slides on the, it ran off to the bottom. So anyway, 50 ohm impedance for the feed line, and you want your termination to be 50 ohms as well, and then it'll look good to your radio. Why is coaxial cable the most common feed line for amateur radio? A, easy to use, requires few special installation considerations and tools. Okay, what is impedance? A, the opposition to AC current flow. Now, just a quick question, regular resistance affects AC also, right? Yeah. Okay, what is the unit of impedance? What unit is it measured in? D, delta, the ohm. Feed lines and connectors. Let's see, most amateur radio transmitters have an output impedance of 50 ohms. So no matter which, one of the few things that are actually standardized. Most antennas have an input impedance close to 50 ohms. You notice it says close because there are, manufacturing variances. Either directly or with a matching transformer. So the 17.5 foot antenna that I had, that I told you I used, all it is a wire up on a fiberglass pole, supported by a fiberglass pole, but I had to have a transformer to match it. The 17.5 feet is not a resonant length for any ham band, but it's close enough that it can be adjusted with my tuner on 2 or 3 different bands. So you either are resonant, or you have to have a matching transformer. Most coax cable used in amateur radio stations has an impedance of 50 ohms. And again, they said most because hams are experimenters. So if I've got probably 150 or 200 feet of 75 ohm cable TV cable laying around at the house that I'll probably never do anything with unless I decide to take it apart and make a dipole out of it. RG58 and RG213 are often used in amateur radio stations. RG58, most people will tell you that you can't use RG58 with UHF and VHF, and it is high loss. So if you're using more than a couple of feet, you can use a couple of feet of it to go from your radio to your pass-through if you have a window pass-through. And then on the outside, you use something a little better for your longer run to the antenna. RG213 is what I bought to use with the roll-up Slim Jim antenna, the emergency antenna. And now I'm wondering if 25 feet of RG213 is going to be too heavy, because I'm really going to have to put some strain relief on it there when I solder it to the antenna. Often used in amateur radio stations. Both have an impedance of 50 ohms. They both have an impedance of 50 ohms, but one does have higher losses than the other. I do use, yeah. Yeah. The other, like I say, the 213 is heavier. RG58 is, I use it for all of my HF considerations, HF radios. That's all I've got is RG58, and it causes no problems. The losses are minimal at, in the HF range. But as you start to go up in frequency, the losses of the RG58 start to pile up. It gets heavier and heavier. At 440 megahertz, if I remember right, the loss of RG58 is around 10 or 11 dBs. So, you're talking about cutting your power in half 3 or 4 times to get down to that point. Both have an impedance of 50 ohms though, so either one of them is usable. Well, there's a chart, and you can see, let's see, RG58 is, and there's RG213 there. So you can see, let's see here, 440, so 10, and 10 cuts your power. It leaves you 1/10 of your power coming out, essentially. Okay, so if you're putting out 5 watts, by the time you use, and this is per 100 feet. So if you put 100 feet of RG58 on the output of that radio to your antenna, by the time you get to your antenna, and this is if that's actually putting out a full 5 watts. Because sometimes they bump it a little bit just because it's easier to write 5 watts than it is to write 4.59 watts. So by the time you get to the end of that 100 feet, you're looking at only a half a watt, essentially. But with RG213, right over here, you've only got 4.4 dBs of attenuation. So in 100 feet, a little less than 100 feet, when you reach 3, you've cut your power in half. So you'll be down to 2.5 watts at that point. But a 400 feet, 4.4, you're probably looking 2.5. You're probably looking at about 2 watts at that point. So with my Slim Jim emergency antenna, I'm going to have 25 feet on each. So I'm probably losing 1.5 dB. So, which I find acceptable. 20 feet of this would have been a little bit higher, but I'll be on, the 2 meter would be here. So even better. All right. What is the most common impedance of a coaxial cable used in amateur radio? B, 50 ohms. What happens as the frequency of a signal notice that they put 600 ohms in there. They put 8 ohms in there for the audiophiles because that's typical speaker impedance. I'm not sure what they did to 12 ohms for, but you notice a 600 ohms. They had a slide back there with 600 ohms on it for the ladder line, remember? So 50 ohms is your common impedance for feed lines. What happens as the frequency of a signal in a coaxial cable is increased? Loss increases. That is correct. What is the electrical difference between RG58 and RG213 coaxial cable? See, less loss for 213. And then the other difference between 213 and 58 is about $1.03 per foot. Yeah, RG58 is usually around 30 cents a foot. And you can find it less if you're buying more, but RG213, I think I paid like $1 and I think I paid like $1.40 or $1.50 a foot for that. That's why I didn't buy very much, and I ordered it while the wife was in New York. In practice, using RG58 coax as the feed line for an 80-meter dipole might be just fine. You don't want to use 50 feet of RG58 at 440. We already discussed that, right? RG213 coax cable is not the best choice for VHF or UHF frequency, but it is acceptable in short distances. Air insulated hard lines, coaxial cable is the lowest loss, but remember we said that require, number one, the hard line is expensive, and secondly, the tools to be able to do it are expensive, and you do have to, it's even more sensitive to water than your regular coax is. So you do have to seal everything up. Most repeaters, for example, use the air insulated hardline coax cable for the feed line. Do the clubs hire somebody to do that, or do they run the hard line themselves? Yeah, because right, right. Yeah, so I mean, bending that stuff to get it to where you need it to go, and being sure that everything is sealed up well. Which of the following types of feed line has the lowest loss at VHF and UHF? C, air insulated hardline. And why don't we use air insulated hardline? Expensive and yeah, needs special tools and all. Okay, many factors can cause losses in a coaxial feed line. Water intrusion causes a change in your dielectric. High SWR, reflected power dissipates in heat. So just changing the height of your antenna will cause a change in the SWR. So multiple connections in line. Let's see, multiple, okay. I'm sure that it comes down to frequency also, but when I was doing DirecTV installations and dish installations, it was a big thing to make sure that you minimize the number of unions, but that was the best way to do it. I mean, if you've got 150 feet of cable going from the transceiver to the antenna, which, you know, obviously we're talking about a business, and you find a damaged piece of how it got damaged, I have no earthly clue, but the best way to repair it was to cut the damaged part out, and it wouldn't reach, so I had to put a jumper between them, which meant effectively 2 unions, but each union has a connector at each end. So it does bump the signal down a little bit, but it's a lot easier than pulling 150 feet of cable. Yeah. And I think that's what I was getting at, was I think that's frequency dependent, because you're looking at microwave frequencies for the satellite TVs. So you want to limit the number of connections in your line. Loose connectors, loss and intermodulation distortion. Okay. So you do want to make sure that you get your connectors on tight. If it's a permanent installation, they're going to be outside, then there's ways that you can protect against that. But it's usually a multi-step attack to protect it, because the stuff that's going to hold and protect it and still be able to come off when you need to make a repair is not necessarily what's going to be resistant to UV or resistant to rain or resistant to freezing, which we don't fortunately have to worry about a lot here. So there's things you can do, and you can talk to people in the clubs and they'll tell you how they do that. Right now, all of mine is loose because I'm not really satisfied that everything is going to be permanent yet. Which of the following is a source of loss in coaxial feed line? All of these choices are correct. That is a fact. Feed lines and connectors with moisture. Moisture contamination not only causes higher feed line losses, but moisture can also cause coaxial cables to fail. If it gets in there enough, we've talked about, well, actually, we didn't talk about in here, but I've heard conversations about things rusting on people's towers, those who are fortunate enough to have a tower to put an antenna way up high, and ground connections and things rusting. Well, the same thing can happen inside of your coax. I mean, you get water inside of the coax, it changes your dielectric, it can cause corrosion on the copper parts inside there. The pin is usually brass, right? The pin in your connector is usually brass. Yeah. Let's see. So moisture can enter through cracks in the outer jacket. So ultraviolet light. Ultraviolet light gets, if you're going to have coax, it's going to be outside. You want to make sure that it's resistant to UV. And the same thing goes for the rope that you use to suspend it. I'm on my second rope right now because my first one I put out there was red, which I liked because it was more visible when I could see it. But when I did the research after it fell, I found out it wasn't UV recommended. So it lasted about 6 months before it just rotted away from the UV and the rain and collapsed. The one I've got up there now is UV resistant and weather resistant. The key to UV and weather resistant is that you look for the best price that you can find that's either designed specifically for radio or specifically for marine applications. Because if it's designed for marine applications, it's good to go for the weather. Air insulated hardline is also susceptible to moisture problems. A hardline requires special techniques to prevent moisture from getting inside of the cable. Now, we're not just talking about running water getting in there, but because we live in Florida, the air inside there has to be purged out with dry air as they're putting it all together. Otherwise, it'll just condensate in there. To prevent moisture inside the cable. Which of the following causes failure of coaxial cables? Okay. A, moisture contamination. Solder flux contamination can affect anything that you've soldered. It doesn't necessarily have to be a cable. If you don't clean the solder flux off of there, that stuff is slightly caustic. So, rapid fluctuation of transmitter output power. I'm not sure about that. 100% of duty cycle for an extended period of time will cause things to get warm, but it's not going to cause failure of your coax unless you're using more power than what the coax is rated for. Why should the outer jacket of coaxial cable be resistant to ultraviolet light? D, ultraviolet light can damage the jacket and allow water about said weather, can allow water to enter the cable. What is disadvantage of air core coaxial cable when compared to foam or dielectric types? It requires special techniques to prevent moisture in the cable. Takeaways: impedance, opposition to AC current flow. Expressed, the unit that it's expressed in is ohms, just like resistance. Feed lines, coax, easiest to use because it has no special installation requirements, just some simple tools my set of tools. And to give you an idea, I think I got my crimper with 5 sets of jaws and a prep tool and a set of wire cutters. I think I got it for like $50 or $60, but you can get them on like DX Engineering or maybe on Gigaparts or something like that. You can get much better quality tools. And if I ever have to buy a second one, I will probably go for the better grade tools. But right now, let's see, the hobbies that I've been through in the last 10 years, my wife says, no, let's wait and see how long you're going to stick with it before we spend money on the heavy tools. Feed lines, coax is easiest to use, no special installation requirements. 50 ohms is the most common impedance. Loss increases with frequencies. So as your frequency, as you move to a higher frequency band and a higher frequency band, the losses jump up there. RG213 has less loss than RG58. Air insulated hardline, lowest loss at VHF or UHF, requires special tools. Let's see, causes of destruction of your feed line is water, connectors, high SWR, UV damage. And stop recording.